All right, let's solve this system of equations, right? So we've got a system of 3 equations and 3 variables. They're already in standard form, so we don't have to worry about that. And now what we're going to do is we're going to start with the steps, right? And we're step 2, rather. And we're going to pick a pair of equations. Now we want to pick a pair of equations that's going to be easy to solve. So right away, I have this one with the z and this one. So right away I can just multiply the first equation by positive 2 and I'll have, and so I can solve this one easily, right? So let's take these two. So I'm going to group these two. And so I'm going to do what? I'm going to do 2 times 3x minus 2y plus z equals 2. And then I'm going to take 5x plus y minus 2z equals 1. Okay? And so now, when I multiply this out, what am I going to get? Now I'm going to erase and stuff. Obviously, you guys won't be able to do that. But if I multiply the 2 out, I get what? This becomes a 6, this becomes a 4, and I get a 2 here, and this becomes a 4, right? So then I end up with this, and then of course when I add, what happens? These go away, and I get 11x, what? This becomes minus 3y, and this is equal to 5. Okay, so now I've got one of my 2 equations that I'm going to do. Now what I'm going to do is I'm going to take another 2 equations. Now the 2 equations, and again I want to eliminate the same variable z. So another easy pair to use would be this one and this one, because now all I have to do is multiply the first equation by negative 3, right? So let's do that. So if I do negative 3 times 3x minus 2y plus z is equal to 2, and I take the third equation, so that's going to give me 4x minus 3y plus 3z equals 7. And again, if I multiply through, I get what? I get negative 9, I get plus 6, and I get minus 3, right? So I can drop this, oh, and of course, minus 6 here. Okay? So again, if I multiply this by negative 3, I get negative 9 plus 6 and a negative 3, or minus 3, and then a negative 6. Okay, so now if I add down, I get what? I get negative 5x, and then I get plus 3y. These go away, and I get 1. So now I've got my second equation, right, in x and y. This is my first equation, x and y. So now what I'm going to do is I'm going to use, now we're in step 4, right? So now I'm going to use these 2 equations and solve for x and y, right? And so we could use the substitution method or we could use the addition method, doesn't matter. So let's write these. So this is going to be 11x minus 3y equals 5. Now the cool thing is they're already, these 2 equations already have opposite values for y. So let's just add them, right? Easy. This is easy. So if we add these, we're going to get, these are going to drop out, and we're going to end up with 6x equals 6. And what does that give us? Well, if we divide by 6 on both sides, we get x equals 1. So x equals 1, and now I'm going to solve, now I'm going to put the value of x into one of our 2 original equations here. So I'm going to choose the first one. So we're going to do negative 5 times 1 plus 3y equals 1, right? Okay, now I'm going to solve for y. So this is going to be negative 5 plus 3y equals 1. So I'm going to add 5 to both sides. And so what happens? I get 3y equals 6, which then gives me what? Y equals 2. So now I found my x and my y, and now I just have to the fifth step. Right now I'm step 5. Now I'm going to take these values and I'm going to plug them into one of the 3 original equations. Okay, doesn't matter which one, whichever one you want to do. So let's do the fifth one, right? So let's do 5x plus y minus 2z. Okay, so now let's erase this. Okay, 5x plus y minus 2z is equal to 1. So now I'm going to plug in 1 for x and 2 for y. So this is going to be 5 times 1 plus 2 minus 2z equals 1. So now this is going to be 5 plus 2 minus 2z equals 1. And then it's going to become 7 minus 2z equals 1. And now what I'm going to do is I'm going to subtract 7 from both sides, right? And so that's going to be what? That's going to give me a negative 2, right? So I'm going to get negative 2z equals negative 6, right? And then if I divide both sides by negative 2, what happens? I get z is equal to 3. And so now my ordered triple, I'm done, right? So now my ordered triple is what? 1, 2, 3. All right, so now, so how would I write my solution? Okay, now my ordered triple is 1, 2, 3. Now the first things I would do is I would go back and double check and make sure that this point, this ordered triple, satisfies each and every one of these 3 equations. Now I'm not going to do that. I'm going to encourage you to do it on your own. Make sure that they work. Okay? Now once you verify that they work, then the way you would write this as a solution is you would say the set of what? It'd be the set just including this one point, because this is the only point that satisfies. That's all we got was the one point of 1, 2, 3. All right. That's it. See you next time.